Welcome to a lesson with Dr. Powell. Let's take a look at an example of an injective function with domain R2 and codomain R3. Okay, and let's define it as g of x comma y is equal to x plus y comma x minus y comma x minus y. All right, so how do we know if something's injective? That's if all the fibers, none of the fibers have more than one element, meaning the fibers either are empty or they have just one thing in it. Okay, just a single element or empty. And that will guarantee that it'll be injective. All right, so let's just think about this for a minute. Let's just pick any arbitrary codomain element like A, B, and C. And we want to see what the fiber looks like of ABC. So ABC is a coordinate point in R3. So we're going to find out what maps to ABC. What's the fiber over it? So that's like having a system of equations, just like this. This one, this one, this one, and working with it and trying to find all XY pairs in the domain that would actually give us that. So we work with that system, and it turns out that x minus y and x minus y right here, these two guys are the same. And if we look at this equaling b and equaling c, the only way that we're actually going to get an xy that'll actually hold here is if this c and b are the exact same. Meaning that if b is not equal to c, then we're going to get a contradiction in our solving this system. For instance, let's just look at this. What if you subtract one equation from the other? On this side, we're going to get a 0. On this side, we're going to get a b minus c maybe, or something like that. So notice that this only works if b is equal to c. That's the only time we have a hope for a solution. If b is not equal to c, we'll get no solution here, meaning that the fiber will be empty. So if b is not equal to c, we have empty fibers. Now, if b is equal to c, really, we can just focus on these two equations right here and see what happens. Okay, so we have x plus y. So we look at our cases, right? When b is not c and when b is equal to c. And notice those are opposite cases, and so we can work with that. So we have x plus y is equal to a, and we have x minus y is equal to b. Okay, now if we were to add these two equations, we would get 2x is equal to a plus b, meaning that x is equal to a plus b over 2. That means the x value has to be this. That's one value, depending on what a, b, and c is. So in our fiber, all the x-coordinates have to be this. Now, if the x-coordinate is this, notice that y will be determined by either one of these, because if you throw this in here, we're going to be able to solve for y and get out what it is. Y will be equal to a minus this guy, for sure, and that's a well-determined element dependent upon what a, b, and c are. Therefore, it looks like we have empty fibers, but we also have, when b is equal to c, the fibers have exactly one guy, one element. So for sure, what we have just shown is that this function right here is injective. Thanks for watching.